for everyone interested in my oscilloscope project. This is I think the 5th video. I've now made the high voltage unit complete, and again on wood with brass nails, and now here also the say DC part, say the tripler, the rectifying unit is on that board. You can see it here, quite dark perhaps, but anyway, and all the connections to the tube are made. Demonstrate the circuit once again. There was one important thing to tell. There is also in this tube pre-acceleration of the the electron beam here, and that is pin 12, and I had connected pin 12 here to this location in the voltage divider here. So here it goes to pin 12, but when you don't use it, it also works. But this is after new experiments, the better way to make it. Anyway, so does it all work? Yes, it all works. And here you see, for instance, that's very funny to see, I've now connected here to the horizontal plates an AC transformer. It gives out approximately 90 volts for the horizontal plates, and on the other plates, the vertical plates, I have connected my sine wave generator. That's here. And when I tune it, the sine wave generator, to a certain frequency, we can see the sine waves, say, rolling around on the frequency on the horizontal plates, and that's directly visible here. So you can see that. I put down the camera for a while to show what's happening when I change that frequency that I sent into the vertical plates a little bit. Let's see what happens. It's now, by the way, on 0.3. That means the frequency is between 380 Hertz and 1.9 kilohertz. And that directly shows that when you have here a sweep, it's not a real sweep, of course, it is 50 Hertz AC sine wave used for the horizontal line here, and you can directly see the pureness of the sine wave, at least when your sine wave generator works in the order of 20 volts output, because there's no amplification now inside the oscilloscope. So we pure look to the 20 volt present on the vertical plates here. And there are interesting conclusions. At first the sine wave is pure, and when I look to the book of 1939, there is a relation between here all these points, say how many sine waves are showed compared to the 50 Hertz sine wave that is sent on the horizontal plates. So I have to count according to that 1939 book 1, 2, 3, 4, 5, 6 or so. It means that, or 7, it means, of course that's not precise, but anyway, it means that the frequency that I sent in to the horizontal plates must be approximately 9 times 50 Hertz. Is that right? Well, 9. Yeah, yes, that's quite right, I think. That's of course all radio theory, old school radio theory, but still valid of course because it's pure about physics. Anyway, I turn now the frequency of the sine wave generator to another frequency, and when it gets lower we must see less points here, and when it gets higher we must see more. I now go to higher. So, and it's clear to see here that we now have, say, more points to count. Well, that is of course the most primitive way that you can think of when you want to say look at the frequency or watch what frequency is used in a certain circuit. This completely primitive, but in that 1939 book it was properly explained, and of course it's still valid. So let's go back to a lower frequency. Well, now my oscillator stops. Let's go to 50 Hertz and see what happens. Now I am in the order of 50 Hertz. You can see that the horizontal plates and the vertical plates are driven. This is 50 Hertz and the other one is in the order of 50 Hertz. So let's look. And there is a certain moment here where these frequencies are the same, as far as I can see. So now this must be approximately 50 Hertz. And well, it also means, so we see this going on and off, it also means that we can get to a certain better, say, way of showing it. Of course, this is very old school radio tech, electronics tech, etc. Well, that doesn't succeed at the moment. I wanted to get an ellipsoid form or a circle. Don't know why that does not want to happen, but anyway. Well, there is of course an explanation for that, but at the moment, oh well, here you see, say, the kind of ellipsoid, more or less. So, that was all. Thanks for watching. Very, very simple idea of using an oscilloscope in the 1939 way, but of course also in the 2025 way, because this is pure how waves behave on these frequencies, and it's made visible. Thanks for watching.